All right. So let's start, right? So here's what we're looking at. Right. We're going to take a look firstly before we jump into right angle triangles. We're going to take a look at the types of triangles. All right. Anybody can list out the types of triangles?
Isosceles, equilateral.
Right. So let's take a look at here. Wait, sorry, I wasn't listening. Sorry about that.
No.
Let's take a look at types of triangles. So can you go back? I had nothing there, Shannon. Right, no, I'm now starting trigs. I didn't do anything. I was just telling you the topic to do next. All right, so we're looking at types of triangles. So there are two main types that you could break it down.
Right angle.
Right, yes. So you could break it up into these two here. You could break it up into right angle triangles. Right? Let's do a quick little example here. Right angle triangle looks something like this. Right? Watch this here. If you look at it there, right, the 90 degrees here. Are you okay with that? Yeah, opposite the 90 degrees is what we call the hypotenuse. I don't want to spell it wrong, so I put HYP. Right? Right? Opposite the 90 degree, which is here. Right? The 90 degrees there, and opposite is the longest side called the hypotenuse. Right? If I were to make this angle here theta, right? You're right. Opposite is here. This is the opposite. And here is your adjacent. Right? The adjacent is the one that helps make the angle.
But it won't be right angle and the angle on the same line.
The one with the right angle and the
angle on the same line.
But if I change theta up here,
then it would be where
on the next side. All right, I understand what you're saying. Yeah, that's right. The opposite the right angle is a hypotenuse, and the adjacent helps make the angle. Right? Anyone that helps you work out. Right? So if your angle is here, opposite is here. Right? Right? Of course, we should know that hypotenuse is the what?
Long term.
Right. This is the longest side. Right? This is the longest side. All right. So that's the first type of triangle. Then you have your non-right angle triangle. Right, I want to show you something with the labeling to make sure you understand how we label up non-right angle triangles, right? Right, watch this here. When you're labeling, right, angles get capital letters, lengths get common letters, right? So watch this here. If here's capital A, then opposite that length is a common E, right? If here's capital B, opposite that angle is your length, common B, right? If here is your capital C or uppercase C, then opposite is your lowercase c, right? So lengths, common letters, angles, capital letters. All right? So these are the two types of triangles that we're going to focus on. right angle, non-right angle. Right, ready? Let's focus on rules that control right angle triangles. All right. Non-right angle is the more challenging one. We'll do that later on. Let's focus on right angle triangles.
The non-right angle is when you can
Sine and cosine. Actually, you know, you could use sine and cosine for everything. Sine, cos, tan, right angle, non-right angle. I'll show you all how to do that, right? But let's focus on right angle triangles, right? So draw a quick right angle triangle there. Right, let's see here's theta, here's the hypotenuse, here's the opposite, here's the adjacent, right? So we need the rules that control it. All right, you see them? Right, so we need the rules that control them. The first rule, right? The first rule is called Pythagoras theorem, right? I'll put it in red, right? Right, Pythagoras theorem, and this rule basically says that hypotenuse squared is equal to opposite squared plus adjacent squared. So if you take all the lengths and put them into that formula, right, it should hold once it's a right angle triangle, right? So we're going to spend some time on this first rule here. All right, so suppose I gave you a problem like this, right? I gave you a right angle triangle. Let's say I gave you a right angle triangle, right? And the right angle triangle had size pi, 4, and x. And I asked you to find it. Right? First thing is what? First thing, we have to check and see what type of triangle it is. Right? What type of triangle is that? Right angle, right? Right angle triangle. So that means that since a right angle triangle, we know that hypotenuse squared is equal to opposite squared plus adjacent squared, right? Since it's a right angle triangle, we know those rules will hold, right? Now, what's the hypotenuse? The hypotenuse is? What's the opposite? It don't really matter for now because I didn't give you the angle, but let's use 4, right? And then adjacent is x squared. What do we need now? We need to make x the subject of the formula, right? Right. If you look back at the rules I gave you last week, switch the 4 squared and x squared with the 5 squared. Whatever you want to find, put it on the left side. Right? And then make x squared the subject of the formula. X squared is 5 squared minus 4 squared. X squared is what? 25 minus 16. X squared is equal to 9. When you carry across squared, what you get? So x is the square root of 9, which is 3. Right. Remember the square root of 9 is plus 3 and minus 3, right? But we don't need the minus because that's not valid here. So therefore, x is 3. Any questions online, Olia? Any questions there? So there are some numbers I want you to learn off, right? Well, at least when you see them, you know. If you look there, you see in 5 and 4, right? 5, 4, and then when you add in the 3, right? That's a Pythagorean triple. So these numbers always go together. Once it's a right angle triangle and you see 5 and 4, the last number is 3, right? So I want to give you some numbers to learn. So you don't matter work this out. You can watch it. Right angle triangle, you know where it is. All right. So let's make a little note. I'll write it here in blue. Some numbers I like it to know, right? Make sure I'm spelling this right. Pythagorean triple. Right. So the first one is 3, 4, 5. I'll give you a next one. 6, 8, 10. So once you see these numbers, you could have an idea. Right, our next popular one is 5, 12, 13. I'm gonna give you one more. What's the next popular one? 9, 12, 15. Many more. I just giving you some, right? I want to show you how to use it, right? Sometimes you don't even need to work it out. You can watch it and figure it out. 3, 4, 5, 6, 8, 10, 5, 12, 13, 9, 12, 15. These are just some. For your homework, you can look up some more. Right? See if we can add in a few more. 5, 6, 7, 8. So we can add in another 4 more. I like you, we have it. So Google it already.
Yeah, I will.
That's good.
They give me up front and also, right?
Don't go too big, right? Just go 2 digits and 1 digit values, right? So I want to show you how to use it. Too small? You see it? All right, too small, tell me, right? Remember, all is accessible online. You can look back and check it back, right? If you forget, go it over. The videos are a little long, but you could, right? You could run through them and just pick out the parts that you're lost with or get confused with. All right. I can turn? Yes? All right. So I want to show you how to use those triples, right? No working required, right? So watch this here. Let's say I give you a right angle and here's 10 and here's 8. X is how much? 6, right? Easy, right? Otherwise, you'd have to go and work it out something, right? So once you see that it's a right angle, then the next value missing from that triple is 6. Yeah? X is how much here? Oh, are you sure? X is? Very good. Are you okay with that? Right, so you do matter go and work it out. 2, 3,
still be right in you go.
Well, that might be a good idea. Right, let me give you one more. X is how much here? Samira beat all you already. 12. Samira done message answer already. Yeah, Samira done learn that already. Are you okay online? Alejandra, are you okay there? Ishana? Wait, Ishana do be in this class? He's only come to class, huh?
Yeah.
Are you okay with that, Manny? Are you okay? Right, so what I'm showing you there is that you do have to go and work these out, right? You do have to go and work these numbers out. But if you don't know it, like this one here, you'll have to work it out. So work out this one here for me, please. $21. Try this one here, work out X, please. Try to work out X. Those who online message your answers, don't forget. Shh. You have to work it out, and you have to work it out twice for that. Work it out 3 times. Work it out. Work it out. Those who online message your answers. Definitely. All right, nice message answers, all you. I love Suega, calculator, right? No. Try to know that.
Table what you got.
Wait there, right? Right, nice. So I am seeing some good answers. X squared is 21 squared plus 28 squared.
Yes, sir.
X is the square root of 21 squared plus 28 squared, which is 35. Not bad. Right. So we have an idea about that. How to make this harder, boy.
Make it
That's a good idea.
Make it
That's a good idea.
It's a good.
I'm gonna see if I remember what we did. I just want to see. All right, let's see if we can do this. This one a little bit harder, yeah? Same concept, it's a little bit harder. Right? Don't get too frightened. I just put in a next value into it. So I'll give you a triangle here. No angles as yet.
Because it's fun. Yes. I think I give a very proper example of a side and I know the circle. No, sir. So like what you doing? Oh no, sir.
Yeah.
I think I can put too much in.
No, you can do that mentally. It has two ways, mentally and a long way. I'll do it both ways. I'll do the long way and the short way. Try it. Right, those who are online, the last one was correct. Very good. Try this one here. Shannon have an answer already. Shannon, what? Yes, now we'll see. Yes, now we'll see. The answer is what? Wait, you're thinking. Shannon, you're close, but not right.
Oh my God! Wow, I know realizing. Hey, this is algebra. Like that. Try to check. Just do I not it and algebra approach this. Exactly. Are we doing algebra?
Any answers online? You have it? You're real close to it though. I'll show you both.
Hey, what do you found? I don't know that. No, I don't know that. It's on there. Okay, no, I lost. No.
Anybody have it? Any answer here? Right, so you can use the formula hypotenuse squared is equal to adjacent squared. Get it right height here.
I was right. Where is that my group? 9.4 bed. So my answer is 9. It's 10. I don't know.
Right, so waiting to see. Let me see. I've seen some okay-ish work. One person get right so far. Berenger get right. Samira, check it back. Nathan, nah, try again, Nathan. You have the right idea, but some wrong. Melina, you too. You're close, Nathan. You have the idea, you know.
I get 10 and
Nah, Nathan, close. Huh?
yeah, 9 10.
So I'm gonna show you both. I'm giving you a minute. Ishana, correct. Don't message her. Eh? Ishana, if anybody message you, don't give them the answer. Eh?
You really make me come out then.
Danielle, not Danielle. It's a nice whole number. There's a whole number here. Last minute. Nathan, correct now. Shannon is a positive value. It wouldn't be negative. Giovanni, close to it. That's not it. Anybody else? What y'all try? Any more answers here? Any more answers here? All right, so I'm going to show you, right? Method 1. I'm going to show you using the triples, right?
Yeah.
Triples is what?
6,
6, 8, and 10. So it means, wait, no. So it means that x minus 1 is 10. So x is 10 plus 1, which is, right? 11. That's the long way. I mean, that's the short way. What's the long way, right? Method 2. Method 2, what is here? Hypotenuse squared. Hypotenuse squared is equal to adjacent squared plus opposite squared, right? Well, what you all forget to do is to square the x minus 1, right? So let's see what we'll get. X minus 1 squared is equal to 64 plus 36. X minus 1 squared is equal to 100. Here we have two options, right? We could square root both sides, or we could expand it out. Because I showed you all how to solve quadratics, I want you all to do the long way, right? So square it out. X minus 1 by x minus 1 is 100. So x squared minus 2x plus 1. We bring across the 100 and you'll get, so you'll get x squared minus 2x minus 99. And then you're going back to the formula I taught you all a while ago. Minus b plus or minus the square root of all over 2a. Right? This is a long way. That's why I said this is a long way. Right? And you'll get x's 11. And a negative number where you wouldn't take that. You'll ever saw that formula before? Or then use it. All right. I'm going to show you how to use it, right? For those who are new, I'm going to show you how to use it. Right? The value in front here is A. The value in front here is B, and the value here is C. Right? So A is equal to 1, B is equal to minus 2, C is equal to minus 99. Right? Although we could factorize, and I show you how to factorize as well, right? All right. Yes, let's check out Daniel working here. Yeah, that could work, Daniel. That could work. I just want to show them the long method. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 by a. So you'll get 2 plus or minus the square root of, what's the value inside there? What's 99 by 4 plus 4? 3.
Oh, you're adding.
Yeah, adding the 4. 400. 400 over 2. So when you work this out, you'll get 2 plus the square root of 400 is 20. All over 2, which is 11. All right? I know it's a little long, but you all have to be able to solve a quadratic, right? I want to show you one last method. When you reach up here, right? When you reach right here, you could have written x minus 1 is the square root of 100. X minus 1 is 10. X is 10 plus 1. X is 11. Okay? So I showed you 3 methods there to solve the same thing. The first method will not always work, right? Because you may not know the Pythagorean numbers. All right, so if you get a quadratic, you have to be able to solve the quadratic. Sometimes you wouldn't be able to factorize it, right? Sometimes you will have to use this long formula and work it out. When you get enough practice, I'll show you how to use it on the calculator as well. You send a picture, oh yeah, Virendra. Yeah, that could also work for Virendra. That's like the third method I showed you there, very good. Right, that's like the third method. Ready? Let's go again. Anybody writing online? All right, let's do a couple more like this and then introduce trig ratios, right? That's like sine, cos, and tan. Just one more, just 2 more like this. I can change it. I can change it. This is writing, boy.
Sorry.
Yeah, today.
Right click.
Amen. Number 7. Try this one, please. $18 and 24. Any method you want. Third method is the best, right? 18, 24, x minus 3 squared. Right, if we get value somewhere again. Try to message your answer. Finish? Finish? How much you got?
No, I don't want that. I want to hear.
Next one. Yes, sir. We are here. Yes, ma'am. Go ahead. Go ahead.
I agree.
Go ahead. Very good. And yeah,
Yes, it's
very good.
I look at it all.
How much you got? Yeah,
Better?
I think so. Nice, you got through. All right, so let's see. Let's see, what did I use there? 1824. Right. So let's see. Should be a nice whole number. So hypotenuse squared is x minus 3 squared. Oh wait, why did I put squared here?
You wasn't supposed. So this is why I like.
Right? So x minus 3 squared is equal to 18 squared plus 24 squared. No, I'll work it out. Correct. So that would be x minus 3 squared is equal to what 18 squared plus 24 squared is 900. right? Carry across is squared. And you'll get square root of 900. So x is equal to 30 plus 3, which is 33. Try one more. It's my fault for putting that square there. But some of you will ignore it anyway. Add a square here first. Hello? Okay.
I thought wondering that you know what happened to what square or what square. Okay, yeah. Okay.
All right, sorry about putting that square there, really and truly. If I had that there, it was to put to the power of 4 and all kind of. But that's my fault. Somehow I feel that's what Nathan did.
Yes.
So Nathan, technically you're right. All right, so let's see. Here is 35. Here is 21. And here is x. Let's change it from a minus to a plus. Solve for x. 35, 21, solve for x. Last one. Last one. Come on, if very good. Any answers as yet? Should be a nice whole number for this one. Wait, how again fractions?
I get 26.
That's not.
Should be a nice whole number.
I get 26.
I'll tell you. Wait, don't say the answer out loud now, it could be wrong.
So we'll let them pick up the wrong answer.
All right, let me see if anybody get it right. Samira get it right so far. Giovanni get it right. Jamie get it right so far. Check it back. If I didn't call your name, check it back. How much you got?
I get 26.
How much you got?
So you don't know what you want.
Any more answers? I have Daniel alone here. Daniel, correct? Wait, Daniel, how you get that right? Oh, you do it up. Wait. Something a little fishy here, Daniel. You do it right, but you still at a square. Up till here, right, Daniel? Sunday there for you. Up till there, right? Kamani, you closed it. Check it back. I feel I know what I did wrong. What's the hypotenuse there in this example? 35. So the longest side should be 35, right? Right. I'm gonna walk around and let's see what I see. Where you? Get 26. No. You should get it. Yeah, like I'm saying, with your fish.
I need to start this whole thing over. Don't correct this. Yeah.
All right, let's see what you have. Let's see what you have, right? Right. Good job, Shannon. Good job, Varinja. Let me see who else fixed it. Ishana, you're close to it. So watch this here. One of the mistakes I've seen is that you all forgot that 35 is hypotenuse, right? So 35 squared is 21 squared plus x plus 2 squared, right? So just carry across the 21 squared. So 35 squared minus 21 squared is x plus 2 squared. So it's 35 squared minus 21 squared. Anybody have that? What's 35 squared minus 21 squared? How much is that? 35 squared minus 21 squared. 784. So 784 is equal to x plus 2 squared. Let's just switch them around. X plus 2 squared is 784. So x plus 2 is the square root of 784. How much is that? Square root 28. So x plus 2 is 28. X is equal to 28 minus 2. X is 26. Right, so I was kind of hoping you see something wrong when you recognize you got a length longer than 35. But that was excellent. What's your name again? Kayla. Very good, Kayla. Very, very good. I like how you make opposite the subject at the formula from the beginning. Very, very good. All right, so good. Let's go back to something easy now. All right, I'll just challenging you a little bit there. Everybody okay with that?
Yeah.
All right, so that was well done. Well, some people that was very good. The trick is taking your time when you're making the subject of the formula, right? Take your time. And don't forget the square root 35. Who didn't square root 35?
I don't know.
Very good.
I don't think.
All right. So good. Let's go back a little easy. Right, so I went a little hard there. Let's go back a little easy now. Add up trig ratios, right? That's very good. There you go. I like how you get that last one right. Well, the one before that. Good job. So that means you're ready for the test next week.
What?
What?
Yeah.
Jacob wanted that test, so. Yeah, he just messaged me and said, "Sir, I wanted a little test on what we did so far." Right? Those are the topics that we did so far, right? So I'll give you a little test. Most likely multiple choice or something.
Nice.
Oh, you didn't do some of them?
Yes.
For sure then. All right, I will see.
It will be
I might get a chance to do more videos in time, but so I will see. I'll probably do it on subject at the formula and trigs alone. I will see. All right. Next subheading, trig ratios. All right, trig ratios. So let's say we have the usual hypotenuse, opposite, adjacent, right? There are three ratios that we could use to help us solve anything, right? Yeah, SOHCAHTOA. So sine theta, right? Sine theta represents the ratio of opposite over hypotenuse, right? Cos theta represents the ratio of adjacent over hypotenuse, and tan theta represents the ratio of opposite over adjacent. Right, copy that down and we're going to jump into some examples, right? We have a calculator, right?
Yes.
So what's the word under sine, cosine, COS? COS, cosine, tan. Add her to the group me one time now. Gotcha. You add her on Kayla, right? Everybody here in the group, right? That's Adi, right? Kayla. Started, yes. Ready? Let's try one now. So I'll give you this here, a bit of a calculator, right? Make sure on the top right hand corner, your calculator is in D. Right? Yeah, D. On the top somewhere there, it should be saying D. Right, good. If it's saying R, you have to press D, R, G and convert it to D, right? But you should be seeing a capital D somewhere in the top.
That's what the real confused. Oh.
Yeah, it have degrees, it have radians and gradients. All right, so let's start here. So I've given you, let's find theta. Here's 4 and here's 5. Right. Look at what we have there. I want us to find theta. What do we have? Right, very good. We have the opposite and we have the hypotenuse. Which formula has hypotenuse and opposite in it?
Sine.
Sine, very good. So we're going to use sine theta is equal to opposite over hypotenuse. All right. So we're going to use sine theta is opposite over hypotenuse. So therefore, sine theta is equal to 4 over 5. So we are trying to find that angle here, right? Theta is an angle. So in case you didn't know, when you move sine across an equal sign, it becomes sine inverse, right? It becomes sine inverse. So theta is sine inverse, open brackets, 4 over 5. Go take calculators, tell me what you get. 53.1. Three significant figures, good. Go to calculator, press sine inverse, open brackets, 4 divided by 5, close brackets. If you have a sharp, do it like that. If you have Casio, well, you don't have to worry about the brackets too much. Casio is the way to.
Yes.
Yes, sir. Check it and make sure you're getting 53.1. Yeah, everybody getting it? Online? Everybody getting 53.1? Yes. Nice. Nice. Richard again, true. So you got, okay, nice. Good job, Malini. Ariana, while you're alive there, right? Good job. Right, good. Let's try our next easy one. I'm bringing in no X something, right? Giving it theta. Nice and easy. So we'll continue with this next week and we'll do some past papers, right? We'll do the past papers next week.
So we could bring it to
Huh?
Bring that.
Yeah. The book I did the book you bought from the office, yeah. We'll do all in there.
Yeah.
That past papers in the office.
I am not. Yeah.
But mine, the version that we have is the shrink version. You know, there's a next guy named Mr. Marlon. He has the full length version. It's like what the actual papers look like. How was it shrinked? So it's a little cheaper, but we have everything. It have a little more as well. Past papers. Yes, I'll tell you office. All right, next one here. Number 2. I given you the triangle. You have to figure out.
So it's after every subject you pass it.
No, but I could give him Mr. Marlon number. He should have everything. What subject you need? I do have. Yeah, I think we have a bio. We have bio on here. All right. So try to find theta for me. I am giving you. What am I giving you? I am giving you here's 10 and here's 12. Try to use the right rule and tell me what you get for theta.
So Let me see the number right after the decimal is,
One decimal. Chunk good three significant figures.
I.
Three significant figures.
Yes.
Ready? All I get you? What you all use? Tan, very good. Right? Because we have adjacent and we have opposite. So tan theta is equal to opposite over adjacent. So tan theta is equal to 10 over 12.
Reduce it and get 5.
Yeah. Tan inverse is 10 on 12, which is 39.8 degrees Celsius.
Yes.
I say yeah. Celsius. All right. Let's see if we can squeeze in one more now. Well, what you will do if I gave you the angle? I'm gonna see if you can handle this.
Oh, I can do that. I can do that.
What you will do if I said here's what? I want to see what you will do here. So I'm giving you the angle 30 degrees. I'm giving you 4 and I want you to find x. I just want to see how you handle it. I know I didn't give you an example, but I want to see how you handle it.
Now, if I get it wrong,
It's all about transposing, right? So I'll give you the angle. See if you can figure out how to find x. So figure out the right ratio and then you should get it.
wow, I could have.
I'll find it.
Transfer for x now. Let me see Jimmy. Remember x is hypotenuse. So there should be larger, right? And here's opposite. So what's the ratio you're working with? Sine, very good. So we're going to use the Go ahead. Any answers? Any other answers? Good job, Ishana. Good job, Aliandra. Any answers inside the house here? No answers? None? All right. So watch here. All right. That's what you're doing, right? So we know the angle is 30 degrees. So sine 30, we know opposite is 4, and we know hypotenuse is x. Right? Sine 30 is how much? Go to the calculator. Press sine 30.
40.57.
All right. No, no, you get half.
Oh, I can't.
Right. Sine 30 is a half. So a half is equal to 4 over x. Two fractions equals sine cross multiply. 1 by x is x. 2 by 4 is 8. So the answer is 8. Are you okay with that? See what I did? See what I did there? We're explaining back here. So watch here. I just going into over. So the angle is 30. We know what opposite and we know what the hypotenuse is. So it appears that we could use sine. Okay. So I substitute theta as 30, opposite as 4, hypotenuse as x. That's okay. I went to my calculator and I found sine 30 and I got a half. Right? Now I have two fractions separated by equal signs, so I'm going to cross multiply. 1 by x, 4 by 2. That's okay? Last one for the road here. Last one for the road. And we're done. Ready? Last one here and we're done, right? Number 4. Let me change him up a little bit. I put it like this. Let me give you an angle. Here's 45. Here is 1 solve for x. It mightn't be the nicest number in the world, but put it like 1 decimal place, 2 decimal places. Yeah, this one is decimals, right?
It's not easy.
Right, you won't get a nice number here. You'll get you will get a decimal. How much you get? 1 point. 1.4, yep, that's good. Check up how much you got. Nah. You can sell them, right? You can sell.
Where you get control? Yeah, 1 point.
And let's see. Let's check it out. So what do we have? We have hypotenuse and we have adjacent, right? So it means that we are going to use cos theta is adjacent over hypotenuse. So cos 45 is equal to 1 over x. Cross multiply if you want, one time. Or you could, let's work it out. I know most people did it like that, right? Cos 45 is how much?
707.
Right? All over 1 is equal to 1 over x. Cross multiply, you will get 0.707. X is 1. X is 1 over 0.707. 1.4. 1.41. Okay. Yeah, three significant figure. Yeah, that's degrees Celsius. I know I didn't give you a unit. That's all right. All right. Okay, nice job.